Okay, namaste everyone. My name is Sujan Das, and today I am going to explain about the counter examples. So let me start with the introduction. Then I will explain about the structure of counter example, counter example in real life, counter example in mathematics, methods of proof by counter example in mathematics, counter example in chemistry, and counter example in biology. So let's first start with the introduction. A counter example is the example that disproves the theory or statement. A counter example is used to check the validity of an argument. According to Wikipedia, a counter example is any exception to a generalization. In logic, a counter example disproves the generalization. Counter example is useful in our daily life to disprove many wrong beliefs and wrong facts. So a counter example is used to check the validity of an argument. And now let's move on to the structure of counter example. Let us consider a conditional statement P to Q. If we find a case where P is true but Q is false, then it will be the counter example of P to Q. Let's take one example. If a food is a fruit, then it is an apple. This is the statement. Yeah. If a food is a fruit is a condition and it is an apple is called conclusion. But we also know that there is mango which is a fruit but not an apple. So mango is a counter example. Let's take the counter example in real life. Statement is that all apples are red, but its counter example is there is a Granny Smith apple which is green. So this counter example, the statement all apples are red. Now let's move on to counter example in mathematics. Counter examples in mathematics are used to disprove mathematical theorem. For example, let's take one statement. Negative of any number is always smaller than the original number. The support example of this statement is if 20 is the number, then its negative is minus 20 and we know that 20 is greater than minus 20. The counter example of this statement is if minus 20 is the number, then its negative is 20 and minus 20 is less than 20. Now let's do the method of proof by counter example in mathematics. If there is no counter example in of any statement, then we can say that the statement is always true. For example, let's take one statement. Every multiple of 20 is divisible by 4. There is no any counter example of the statement, so the statement is always true. Let's take the counter example in chemistry. So the statement is if a molecule is S2O, then it is a liquid. The counter example of this statement is the molecular formula of ice is also S2O, but it is a solid. Now let's take the example of counter example in biology. The statement is all mammals give the directly birth to the young ones, and the counter example of this is the platypus. Platypus is also a mammal, but it lays eggs. So this is the counter example of the statement. Now let's move on to the proof of the real number x and y such that modulus of x plus y is less than or equals to modulus of x plus modulus of y. We have three proof for this. Now let's take the whole square of modulus of x and y, which will be equals to x plus y whole square, and if we open the expression it will become x square plus 2xy plus y square. And since we know x is less than or equals to modulus of x and y is less than or equals to modulus of y, so we can say that x square plus 2xy plus y square is less than or equals to modulus of x square plus 2 modulus of x into modulus of y plus modulus of y square, which will be equivalent to modulus of x plus modulus of y whole square. So we can say that modulus of x plus y is less than or equals to modulus of x plus modulus of y. This is the first proof of this statement. Now let's move on to the second proof, which says that for all xy belongs to real number, minus modulus of x is less than or equals to x is less than or equals to modulus of x, which is the first equation. Similarly, in the second equation, we take that minus modulus of y is less than or equals to y is less than or equals to modulus of y. After adding 1 and 2, we get minus modulus of x plus modulus of y is less than or equals to x plus y is less than or equals to modulus of x plus modulus of y. So we can say that modulus of x plus y is less than or equals to modulus of x plus modulus of y. Now let's do the last and third proof of this statement, which says that let x plus y is greater than or equals to 0. Then since x is less than or equals to modulus of x and y is less than or equals to modulus of y, so we can say that modulus of x plus y is equals to x plus y is less than or equals to modulus of x plus modulus of y. Let x plus y is less than 0. Then modulus of x plus y is equals to minus x plus y is equals to minus x plus minus y is less than or equals to modulus of x plus modulus of y. Since minus x is less than or equals to x modulus of x and minus y is less than or equals to modulus of y. So we can conclude that modulus of x plus y is less than or equals to modulus of x plus modulus of y. This completes the proof of the theorem. And thank you for listening to me.